just to let you know how the panel will be going, we'll all do introductions so you know a little about our backgrounds. We've identified 3 questions among the panelists that I'll be asking, but that will just be the first 25 minutes or so, and the last 20 minutes I'll open it up for questions. If you have any burning questions before then, just feel free to raise your hand as well, but we want to make this interactive. So I'll start off with a quick intro for those of you who haven't heard it yet. I am Aarti Bagul. I work at Snorkel AI. We have a booth outside. I lead a team of machine learning solutions engineers there. I joined 2 years ago as one of our earliest machine learning engineers. Before that, I worked with Andrew Ng for a number of years at his lab, helping start some companies at AI Fund, as well as helping release his latest machine learning course. So that's a little about me. Maybe we can go down and you can all just do a quick intro about your backgrounds.
Hi, everyone. I'm Sam. I lead AI and ML product development at Opendoor, which is a real estate company. We use algorithms to buy and sell homes, or kind of half consumer technology company, half quantitative hedge fund. I previously co-founded a company that was using AI to improve hiring. And before that, I worked for a genomic data startup.
Well, we just did the introduction. Maybe one point to add, how on earth did I end up developing AI for things that fly? There was pretty much over a coffee. At the time I worked on autonomous cars, etc. And was over a coffee with some of the executives from Airbus, and described to me the plan to develop an autonomous electric air taxi. I thought, whoa, that is something completely new and different. Let's do that. And and it was an interesting journey to the things that fly.
Hi, everyone. My name is Sravya. I work as a staff machine learning engineer at Adobe. I work in the Gen AI and Sensei platform team, primarily focusing on large-scale deep learning infrastructure. The space of using AI for creativity really fascinates me. Before that, I co-founded a nonprofit focusing on using AI for some of the underserved areas. And before that, I was working at Cloudera. So my experience comes from big data technologies, open source, to high performance computing and like very scientific domains. So it's kind of nice to see my different worlds merging in machine learning.
Hey there, Karl Willis. I'm a senior research manager at Autodesk. I work in the Autodesk research part of the company and in the AI lab. And so we look at using machine learning for problems that relate to design. So whether that's designing buildings, cars, bridges, all of those things we see in everyday life. So a lot of that is creating 3D geometry, could involve things like simulation as well. And so, yeah, working on that area.
Awesome. So going on to the questions, just to let our panelists know as well, we'll be taking 2 or 3 answers per question. So feel free to just chime in. If nobody volunteers, I'll call on you. Awesome. So starting with the first question, which has come up a couple times already today, which is, how can organizations predict which AI projects will deliver the highest ROI for their business?
Yeah, so I had an initial thought on this one that I think part of the challenge is just deciding when you shouldn't use AI. And that's sort of the step 0 is like, is there a solution that exists that is not AI and that you can avoid it, right? Because I think generally you have fewer gray hairs if you avoid it. And then the step 2 of that process is figuring out, okay, if you need to use AI, like, do you have the data for what you're trying to do? And I think once you have those 2 bases covered, and they're pretty big questions to answer, then I think you can kind of move on to, and maybe I'll let some others sort of speak to that. But I think at an initial point, really just considering those 2 things, can you avoid it? Is there data?
Yeah, to add to that, I think it really depends on the space you're in. But in general, I tend to think, in terms of capabilities, right? Like AI, even in terms of capabilities, what AI was able to do like 2 years ago is very different from what it's able to do now, right? Like what we thought was very, very deterministic, are like very suited for software engineering, right? You don't need to have a model to do a code up of system which is very deterministic. But as we see the progress of AI, there are a lot more capabilities which we thought weren't possible. So I think it really depends on what are the new capabilities that are relevant for your space, which were just not possible before. And that's the golden opportunity, right? Like making use of that and thinking in terms of first principles. Okay, if you had to reinvent your product at this age, what would that look like? And I think that's where the interesting stuff emerges.
Yeah, I can add to that. The ROI is a big word, but it pretty much implies the ability to measure over time. But what we look here is a progress that is so fast that it's really more an 0 to 1 jump. Can we do things that are fundamentally different than what we could do before? And with that, the ROI comes later. But the key message is really the 0 to 1 jump, the realization of completely new function with AI, and the progress that we see in that domain it's really fascinating how fast that is.
So I'll comment a little bit on the R in ROI, and this is a framework not necessarily particular to AI projects, but I think it applies more broadly. I think one of the challenges when you're considering a bunch of places you could invest technical team time is that different teams tend to focus on different business metrics. You might have one team that's focused on something like revenue growth. You might have one team that tends to focus on something like profitability. And it becomes an apples and oranges problems of how do I put resources into project A or team A versus team B. I think a lot of that can be clarified by at the group level or at the company level saying we have one North Star and there's some way to translate across metrics. So at Opendoor, one thing we do is we have kind of agreed upon heuristics that we use to say, this is how we convert revenue growth into margin growth. We've measured some concept of elasticity, and now we can actually compare these two projects on the same unit, even though they're fundamentally different types of projects. And it's an estimation, it's not perfect, but allows us to make better decisions about how projects compare to each other.
Makes sense. Just to add to that, I mean, at Snorkel, we work with a lot of Fortune 500 companies, a lot of top data science teams that honestly don't really quantify this ROI or know how to prioritize these projects. And honestly, the sales framework, we lead them through this journey of really what is your current state without machine learning, maybe even. What are the implications of that? What are you trying to get to with machine learning? What are the implications of that? Put some metrics around that. And then see what that impact would be. But being just a little more methodical, maybe even seeing or keeping a single metric, as Sam was saying, to compare projects across, helps you prioritize that effectively. So awesome. Next question. Maybe some of you could give some examples of successful AI projects that have delivered strong ROI for your organizations, and what can people here learn from those examples?
I can kick it off. One class of deceptively simple but generally successful projects that we have pursued relates to routing. So a lot of the time, I think our technical teams and our end users, they tend to focus on, can you make this algorithm better? Can you make it faster or more accurate? Or can you spin up an entirely new algorithm? But for most of our applications that are actually quite valuable, there's some kind of human in the loop check, either at the individual inference level or in terms of groups of predictions. And we've gotten a lot of leverage out of being more thoughtful about how do we involve humans? How do we maybe go to a routing that's more complicated than just no human or one human? Maybe you want multiple humans involved. Maybe the type of human and when they're involved in the process should be segmented. And a lot of the technical lift here tends to be relatively light. For example, if you have a model that doesn't expose some kind of confidence score, simply exposing a confidence score or a standard deviation can get you off and running in terms of doing smarter routing.
Yeah, I can think of like a few examples. on one hand, we have machine learning models making creative process of our users much more faster. For example, one example I can think of is select object removal, right? Like traditionally, if you have an image, a beautiful, family picture, but there is some photobomb, right? Like there's some object and you want to remove that, right? Like those kind of workflows used to take a lot of time to really remove that object, but not, disrupt the aesthetics of that image. So we do have tools which kind of smoothen that path, right? So those were like really useful. Now people can do that job in like a few seconds rather than like a skilled person looking at things for like many hours. And we also have, some of the features which are more like first principles kind of features where the entire workflow is new, right? Like, for example, neural filters, where users can, make a person smile, right? Which was not possible before, right? So I think, So I tend to think like in terms of like, are we doing like a iterative improvement in an existing workflow, or is it like a completely new workflow? And I think we've seen successes in both buckets.
To add on the aspect of what puts a smile on my face, a couple of months ago, we had a demonstrated end-to-end flight for basically in fully autonomous flight with a large commercial aircraft, and basically years of preparation that move into this one moment when basically you tell the pilot, okay, now press the button, then let go. And so the camera running, and you could see the pilot trying to grab the instruments, he let go, and the complete mission is done autonomously. And there was, for me, this aha moment to say there are a ton of challenges ahead, but this thing is going to happen. And one of the lessons learned on that is to expand on the point that Karl brought up. Do we need to use AI? And because there's a price to pay. It's a big machine that we throw at the problem, and it's a substantially different approach, and it can be a very expensive approach. So this understanding, do we have to do it with AI just because it's fancy and new? Can we do it with conventional methods, and only if we understand it cannot be done for a range of reasons with conventional method, then decide on AI. That for me is one of the key learns in applying AI methods for vehicles.
Really great insights here, which is first, see if you even need machine learning. If you do, what is the type of workflow? Is it iterative? Is it brand new? And then think about the operationalization aspect, which is who does it need to be routed to, how many people, etc. So really good insights there. Thank you. The last canned question that we have here is, what is the role of AI tooling vendors in helping organizations realize ROI from AI projects? And what considerations do you generally make when selecting vendors?
Yes, I think just if we look back at the last, let's say, 5 years, there's been this broader shift from these sort of custom, bespoke machine learning models to big models that can do just a lot of stuff, right? And all the students who work in machine learning are kind of pissed off right now because they can no longer do the type of machine learning that's cutting edge just on the GPU that's in their little desktop under their lab. So it creates this divide, right, where we don't to do that kind of research on those big models. There's only certain companies that can do it. So you probably know them, right? So I think there's an opportunity, right, for that type of infrastructure, because it's crazy infrastructure. And if you talk to the people who manage or train these big models, they're literally babysitting these machines when one GPU goes down and the node goes down, and it's this whole dirty little secret of how they train them. And so that is really flaky right now, and I think it has to be systematized, and I think vendors have a role to play there. And I think kind of access to compute, I think the cost will come down, but it's not everyone who's going to be able to have access to this type of infrastructure, right? And even mid-sized companies are going to be in this position where I think they're going to be looking to outsource some of that infrastructure for training and so on. And hopefully even someday those poor grad students will get access to it as well. But that's one area I think in the future we really need to see some progress, and I think it can be commoditized hopefully eventually.
Yeah, I have a talk this afternoon which mainly focuses on this question. I do think this is one of the hardest part of my job. The capabilities at these various layers of ML capabilities are like so quickly changing that the only constant is the change, right? And you have to build the system which can adapt, extend in a modular way where you are at that time in terms of your development and your team size and skill sets. And there are lots of tools out there, which are great. And being able to pick and choose what works for you in a cost-effective way, given the macroeconomics, right, and sustainable way for your team. And nothing, I believe, is like set in stone in this space. And you should be able to. You should have a plan how you'll adapt what you're building today, maybe in a year, right? And that's how you can stay agile and adopt these tools where it makes sense.
You give me all the good talking points. So the speed, how things change, and that automatically translate in for a lot of topics. You just do not have an end-to-end situation that you can buy off the shelf, and for a lot of the topics that we developed, I would love just to buy some end-to-end solution, but since given the speed of the progress here, at the same time understand what are your requirements that you want to develop and how to translate it into a technical solution. That means, in essence, you can try to integrate some parts that you buy, but an end-to-end solution in most cases is simply not available. And there I see a big business opportunity for new companies. So AI development, one big learning is the part where you develop the algorithm is just a small part. The big part is how you do data management, design assurance, quality management. And there I see a huge, open white space for companies to fill. Now the question is how to fill that, because a lot of the how do you deal with data, how do you verify function, that's really domain specific. But I'm surprised how very few things you can actually buy in this domain that helps you to move to an industrial solution.
Startup ideas right here. So
that was my point.
Sam, feel free to go as well. We're running ahead of schedule.
Yeah, my other panelists have mentioned a lot of really good things to consider when making a build versus buy decision. I'll throw on two other things that we consider. One is interoperability. To Arne's point, most of our vendors, they're rarely end-to-end solutions, at least defined as end-to-end in terms of what we think of as a customer-facing product. It's normally, we define a product and a vendor is either cutting across a bunch of different products that we offer, or they're kind of a specific segment of one of our customer-facing products. And so how easy is it for our engineers and our researchers to link that into the broader network of what we do? If you solve that pain point really well as a vendor, but you're not particularly extensible, that's really difficult for us. The other thing that we think a lot about is, do we care more about this than a vendor? So to give you kind of two examples on both sides of this, we care a lot about interior images of homes because we spend billions of dollars every year buying homes. And so we have a belief that we care more about the accurate labeling of what type of dishwasher is this than probably any other company on the planet. And so it does make sense to us, kind of setting aside the technological challenges, that like we probably are more inclined to invest valuable researcher and engineer time in solving that specific problem, because it's not a problem that many other people face. But a counterpoint to this would be, we care a lot about data quality. When we have a table and there's a bunch of null rows or null columns in that table, and we train a model on it, that model breaks and it costs us potentially millions of dollars. We care a lot about that, but so do many, many other companies. That's a very generic problem. And we're very focused on it, and our engineers and our researchers and our product managers have all sorts of requirements in terms of how they want to see that solved. But one way we can evaluate whether those requirements are right or wrong is, are vendors actually trying to solve those? And if a vendor doesn't meet those, is that because like the vendor is doing something wrong, or is that because we have some weird requirements and maybe we should rethink them? And we tend to contextualize all of that in the context of how unique is our problem.
Yeah, really great points around how big is the problem, how specific is it, and the interoperability. I guess speaking from the perspective of somebody who works on selling a machine learning platform, I think it comes down to also calculating the ROI that you would get from the platform to how much you're spending from it, like the value you're delivering. And so part of what we have to do is also make sure, goes back to outlining what is the current state without Snorkel, how much would they be spending on data labeling otherwise? Do they really have a problem? Like, what is the volume of data coming in? Is it like a chatbot where things change very frequently? So just measuring, what is the level of problem and how much would they be spending without us? And then really quantifying that, similar to how you would quantify, as we were talking about, the ROI of the overall project that you're doing. Yeah, so we've been a very speedy, fast group, and we're out of our canned questions. We do have some more that we can go through, but more time for audience questions. So if you do have a question, please raise your hand. We'll give you a mic. A couple of people already.
Thank you. I think the answer will be different for each of the panelists. So speaking to the question at hand, I wanted to get an idea on how important intellectual property protections are for increasing your ROI. So for instance, software patents are some of the most complex and take the longest. But for what you are doing, perhaps you don't even consider that. But for some of you, it may be the most important thing. So could you each comment on that?
I'll give you an answer on one end of the spectrum, and I'm sure others will have it on the other end. But I'm in the research part of the organization, and everything we do, we publish openly. So you can kind of read our papers, and we release the code, and it's out there. So my general view, if you kind of bump this question up a level, is it's essentially what is our moat question? And intellectual property is one version of a moat, but I think where my mind goes is really the data is the moat. And when we think of design data, I mean, we have a lot of it, and I think that's sort of one way of potentially creating competitive separation. But as far as the machine learning models themselves, they'll be out of date by the time the patent is issued. So I think it's just, yeah, it's not something we do very often.
I'm happy to comment next. We do pursue patents. Sometimes that is for protecting our IP. Sometimes it's to recognize the great work of the researchers. I tend to agree with Karl that the timeline for actually getting a patent, we're probably on to the next thing, if not the entire industry has moved on to the next thing. So I think there's a time and place for patents, probably more towards relatively general use cases and how large companies are going to defend themselves against other large companies. But I also see a lot of value in publishing open source, especially as it pertains to attracting technical talent.
We made that switch we started as an open source project, a research project at Snorkel, and then we transitioned into a commercial company. A lot of AI platforms have made that leap. And I think it goes back to Karl's point of IP or your technical ability is just one type of moat. And so we have published a bunch and we continue to, But I think the great thing is all the key contributors are people at Snorkel. So if anybody were to sort of just, people have built some things off of the open source, but we've contributed far beyond that we then don't release. We've patented some aspects. So we have that sort of distribution. But I think the reason why people come to Snorkel is also part of our expertise in terms of machine learning, like the brand, the people who are here, the organizations that we work with. That's hard to sort of recreate from scratch for somebody who creates a platform off of our open source. I saw maybe another question.
Hi, I have a question pertaining to like getting the project approved or the new use case approved. And I was wondering, like, given your experiences, what business teams are most important to get across the line? Because a lot of companies I'm working with, the growing concern is security around the ML models and whether there's backdoors hidden, adopting third-party models, is that safe for your enterprise, your internal models, you know, like how to check that code, all these considerations. So top level question is like, which teams you need to convince and which ones are harder than others, and what's your strategy for that?
I can start with that. Obviously the answer is highly dependent on the industry. The hardest question come from those departments that ensure the fundamental business mantra at Airbus, which is safety. And it's a very AI models are substantially different than traditional deterministic software approaches, and how do you ensure that thing is safe, cannot be spoofed, robustness, etc. Those design verification, explainability, and those are really, really hard and fair questions. So I wouldn't call that as a pushback necessarily, but as, I would say, a verifying question that we need to answer before embarking on that. And then certainly there are questions around budget, etc. If I propose, hey, we need a data infrastructure for petabytes, etc. That of course that raises some questions.
Yeah, I think it also depends on like what stage of project you're talking about. Is it like shipping the project to the end user, or like pitching to a exec that, you know, you have an idea and you want to, you know, it could substantially change your offerings of the company. On the latter side, I think it often helps in like doing like, you know, quick demos. Sometimes, at least in the space I am in, like it's all very visual. So execs need to see what does that new workflow look like, right? Like if you were, for example, pitched ChatGPT to your team like 2 years back, like I'm pretty sure like many would have been like very, you know, skeptical about it, right? Like, so sometimes it takes someone to just put it visually to make a point that, you know, this could work. Coming to the former part of the question, like, you know, if you're talking about in terms of like shipping the project, oftentimes what helps is like having, you know, checks and balances as other panelists have spoken. Like, do you have enough checks and balances to course correct, right? In terms of one, monitor how well your ML model is working, and also have knobs to change that quickly, and maybe even roll out to a small set of users first and roll it out to a broader set of users in an incremental way. So all of these things, mainly because, you know, machine learning models are like so non-deterministic, unlike software where you have a set of tests, you run those tests and you're confident, right? It's very hard. The last mile is very hard in machine learning, where there's always corner cases and you want to minimize that.
Yeah, one thing I want to raise here is ethical review. So we do this, and a lot of the questions it comes up against for us is with how we work with customer data. So, you know, for us as a design company, the things that people are designing, if they're designing a house in our software, that's really their intellectual property, right? Like that's the thing they literally keep the lights on in their building with. So, you know, we really take that very seriously. and we look at those risks associated with it and raise the sort of red flags that need to be raised. So, I mean, just to give you an example, right, of my nightmares at night, you create some large generative model, and generative models have been really good at memorizing training data, right? So think of them as a large lookup table, and they can just retrieve that thing that was carefully designed over many hours and weeks by somebody, and imagine you release some product that then regurgitates that, parrots it out to their competitor. That's when I wake up and I'm sweating. And so I just want to sort of make the point that it's not just always about business decisions. I mean, I guess this is also a business decision, but there's a big legal component to this. Ethical component to it that goes beyond just the legal kind of issues.
So we do have time for more questions. So did somebody raise their hand? Oh, sorry. Maybe I just saw that. Oh, here we go. And then that. Next.
Hey. Hey everyone on the panel, and hey. I see most of you are in managerial roles and leading the team. So I want to understand, for a individual contributor, for a new engineer or a mid-level engineer or a scientist who is about to join, they will be more enthusiastic about trying out the new cool components and everything. How will you, from a managerial perspective or from a senior leader perspective, make them understand that there is a need for the return on investment for the AI projects, and this must be incorporated in your planning and designing? So how will you, what are the pointers you will tell them to tick off, or yeah.
I'm not a manager, I'm a IC, but I can empathize with that question. There's a lot of interest in this domain, and all of us want to be working on cool things. And there's space for that, right? There's green field out there, like so many possibilities. And I think it's important to acknowledge that ideas can come from anywhere. Adobe strongly believes that, ideas can come from anywhere. Having said that, you also have business goals and like deliverables. So I think there's like a balance that what we do at Adobe in our team is like we have a Friday Innovation Day where we have set for, okay, this is greenfield time. Do whatever you want, just demo what's on your mind, right? Like giving some space for really motivated engineers to go out there and build stuff. That also, and honestly, like a lot of good ideas come out of it, but also like time box it, right? And really work as a team in terms of deliverables. So I think that kind of worked.
That ties back to the overall innovation speed in this domain. So basically, as a manager, you have to make a decision: do I perpetually just grab for this shiny new toy on the horizon and never deliver, or at what point do I make a decision? This is frozen, and this is separate for the future. It's actually a very tough decision on that. It really ties into what's your product cycle and what you need to ship, and at what time you just have to say done. At the same time, you have to put the means in place that you really capitalize on this rapid progress in the industry, and get that feedback from individual engineers. And so what we have at Acubed Airbus is you have to express your idea in a prototype, and this can be a really crude prototype, but you somehow have to show what is it that you want to demonstrate, how is it better, and where can you put that, and then what's an allocated time around that, and what are, committed points from the management side. If you deliver this prototype and is doing X, Y, Z, then on the management side, there's also a commitment to carry through. But it's, really, the key point here is it's a curse of this rapid progress. Can you perpetually just chase the shiny toy, or at what point do you commit?
So we have a OKR system we didn't invent it. I don't think it's anything particularly crazy, but I think it can be very effective. we talk a lot about mission to metrics. And so our mission is to make it easier for everyone to move homes. The metrics for the company that are associated with that is how many people choose us to move and how satisfied are they? What's our customer satisfaction? And then every team needs to be focused on one or more metrics. And every individual, every IC who is working or leading a particular project needs to be able to explain how that project ladders up to one of those metrics, which is not a technical metric. And the biggest failure case that I tend to see for ICs, we couple this with putting ICs in situations where they are explaining their projects to non-technical stakeholders who tend to be more senior, is that they can't explain, they're really good at explaining the how and the technical stuff they're going to do, and they can't explain how it ladders up to the metric or the mission. And we're not particularly happy about that. But the flip side, we can be very happy about, right? Like you have an idea, and this is how it will improve the metric and the mission, and you're not really sure of the technical details yet. That's okay. You're sure you have confidence in the impact. Great. You're a great engineer, a great researcher. We have confidence you'll figure out the details. But the opposite is something that culturally we really try to push back against.
One thing I'll add is it depends on like what stage of company you're at. It depends on what team you're on, and it depends on what sort of product you're working on. So startups, more existential, more near term. The team itself, for example, I'm on revenue. We really only care about, well, not we really only care about one number, but we're more incentivized for more short-term prototyping and execution versus our research team, which still works at a larger stage startup, but is more incentivized to do more longer-term thinking. So I think it's like what team you're on. And then, for example, we had somebody from Shipped talking earlier today, Vishal, where even if the technical team has spent a lot of time working on these models, the product is so mission critical that they can't ship it without extensive checks and balances. So it really depends on like where your product fits, what's the impact, the checks and balances you have in place. And that could also affect the types of teams the ICs join and the priorities there. Next question.
Hey, thanks, panelists. Really good discussion so far. The first question that you talked about, sort of how to select an AI project, thinking about ROI. A lot of AI projects are really iterative, and you may anticipate a strong ROI, but it doesn't always come to fruition. I'm curious how you measure that going forward with the project. At what point do you decide to pull the plug, or at what point do you say, I know there's an R in there somewhere, just keep bigger models?
Yeah, so you're asking about where things go wrong. I'll volunteer to talk about this. So I'll save some of the other panelists who are not in research to talk about it. So I think you have this situation, right, where you think something is going to be easy. You take like 2 steps and you realize you're up to your neck in just, let's call it water. And how this manifests is oftentimes you'll do some experiments, and the results won't be great. Then you'll look at the data and you realize, oh, this data is actually really bad, right, for some reason. And then you'll be like, okay, cool. Can we create some more data, collect some more data, do something, right? And you'll get into this thing where actually getting the data is really hard. Oh, let's make a model to generate the data, right? And so you're 1 degree of separation from just even getting the data, right? You're already making a machine learning model to get the data. And then at some point it just keeps on going like that until you realize you have to use reinforcement learning, and then you just say, hey, let's stop. Let's stop. So anyway, that's the sort of situation I think we find in research, where it can be really, really hard at the start to judge if this is a tractable problem. And the only way to really make that judgment is if there's existing work out there that is, really, really close to what you're wanting to do. And then I think you're kind of safe to proceed. But even then, you can find that some of these approaches that people have, they look great in the paper, but then you run the code and you try it on a few real world examples and it just doesn't generalize. So it can be very hard. And, you just, as soon as you just start building machine learning models for your machine learning model, that's when I would just, red flags appear.
Just to add to what Karl said, one of the things I realize is there's also opportunity cost, right? Like just because you can increase the model accuracy by 1% or 5% doesn't mean that you have to invest in it, because there might be another opportunity which is like much, much bigger, right? Oftentimes, I think it comes down to resourcing, right? We have finite resourcing, and we have like a laundry list of ideas. And at every point, we're assessing, like, okay, do we want to keep going in this direction for those marginal benefits, or do we want to, tackle a bigger problem? I think that's what it comes down to, like, given that state of your company and team and the priorities, what's the opportunity cost of investing more in this stream?
All the failures from this panel. We do have some time for more questions. If people have any, we'd be happy to take them. Yes.
Yeah, so with regards to thank you. So when training a model for high impact cases, for example, legal, there's a lot of countries that have large amounts of data, but maybe not in the best formats to train language models. So what are your thoughts about that? For example, taking insights from court cases or different literature within law and restructuring it in a way that's beneficial for training an AI model. Because that's a very high impact area that we are looking into.
I'll just ask a question first. What are you trying to do with that data? Maybe that could help contextualize it for that.
Of course. So we're quite early stage. I'm a startup lawyer who has been amazed by the results my clients have been having. So we're trying to see how we can extract some insights and offer deeper insights with less hours to provide bigger value. So there are some solutions to do this, but we will never be safe to just leave it out there and want to know like what the best way to use vast amounts of public data to create secure insights.
Yeah, some of the things which come to my mind. So just to rephrase your question before I answer, so is the question around like how can we leverage these large models as well as open data for in a domain which is high impact, right? Like there's a cost for a wrong prediction, and how do you? So some things which come to my mind are alignment research, right? Like you've seen in ChatGPT's case as well, where the model has been trained on highly curated question answer pairs by experts, and the purpose of that is to align the model machine to human values, right? Like, okay, when a question is answered, you have to be respectful and you have to be self-aware. When you don't know things, you have to say you don't know instead of cooking up stuff. So there's that, like aligning a large model on what matters to you and your values. And also, I kind of lost my train of thought. Maybe I'll come back to it.
Okay. I can touch on it a little bit. So I don't know if you caught Braden, our co-founder's talk earlier, or yeah, you talked to him. But really, I mean, the way we think about foundation models and the exciting progress is to use it for your task, you have to think about, or one way to think about it is think about how generic is your task? Like, is it similar to data sets that are available? Or is it more specific to your specific, whatever thing you're trying to do? And then how high performing does the model need to be? Like, how critical is it? Like, is 80% kind of good enough, or does it need to be very, very perfect? And you can think about operationalization there as well. And for some cases, like the top bucket, or I'm visualizing a chart, but like things that are super specific and need high quality, you can't get around needing training data that is specific to your task, which is where you can use programmatic labeling to label a lot of data. But no, it's actually true where you can't really escape the amount of training data that you need, and the more quickly you're able to label it, and the more quickly that you're able to iterate, is kind of the only way in those cases. Depends on where you're at in the spectrum. I think as the industry grows, the amount of data you need probably will be less for certain use cases, and you may be able to get away with that.
I was just going to say, completely agree with Aarti. Another thing is, like, you can think of the system as a human in the loop system, right? You don't have to completely set things on autopilot from the day one, where you're just making the human a little bit more productive, right? And gradually rolling it out, right? That's another approach I see.
One other call out, and I've seen this working with systems that are evaluating documents or trained on documents, is for a lot of complex real world situations, the truth changes over time. That's true in law. Precedent will change. The law itself will change. And there's specialized approaches for that, where in your training corpus, you will have different answers to the same question. Different questions leading to the same answer. Models tend to be good at that. They tend not to be good out of the box at same question, two very different answers, both of which are considered rights at different point in time.
Maybe to add, so it's just, the example that I give is a fundamental question of any AI problem. I mean, you come up with a model, how expensive or what's the penalty if the model is wrong? And then what type of quality do you need for the training data, and what type of quality do you actually have in training data? And then in many cases, if it's human annotation, you will realize there is an upper boundary of errors that just get introduced by the human aspect of annotation. And that means at the end, it's really a trade-off. And now how do you get out of this chicken egg problem? I say I would go two routes. One route is just build a system with the data that you have and then see how good it is. And it gives an understanding on where you are, or maybe it's already good enough. And the second is really do a theoretical analysis on giving all the probability models what you actually need versus what you have. And that keeps a good AI engineer busy for a couple of months, and then you have to decide, do you go for the chicken or for the egg?
And maybe one last question, because we do have 2 minutes.
Sorry, this is probably not the best question to end on, but what are the worst practices for realizing ROI on an AI project?
Manually labeling training data. Sorry. Sorry. Please, panelists.
Well, you start with something and then you realize, oh shit, I need way more data, and I don't really understand what I actually want in terms of requirements. And basic realization that may not be the right tool for a problem. And in turn, there is something that's out of your desk drawer that works much better, is there. And you have this big machine that you want to show just because it's AI and it's cool, whereas an existing method that actually works. I'm sure we all have been at that situation, that call.
I would just add one thing. So I think what the point here is, you want to have a baseline that's the existing, and I think I already made this point before, a baseline that's the existing approach, and then probably a baseline of how well a human would do, right? Because ideally you're better than the existing approach and approaching human, right? But if you don't have those kind of guardrails, or like the sort of lower bound and the upper bound, you just don't know where you are, and that can be a really long process.
Yeah, I would like to add an additional perspective: cloud efficiency. Oftentimes I see, money thrown at wrong things, where we're just not using some things efficiently. GPU compute is very, very expensive, and there's a lot of value in optimally using it. That's one area I'm really interested in, and I find inefficiencies.
Paying too much attention to backtesting. One area of failure I've seen is a team that is just crushing its backtested accuracy, driving incredible improvements, patting itself on the back, going out for drinks. And in the real world, the actual metrics that matter, be it user adoption or profitability or whatever, are just steadily deteriorating. But backtesting looks great. And backtesting isn't the real world. If you don't pay attention to the real world, it can lead you astray.
Awesome. And with that, please give it up for our amazing panelists.